Today we'll be discussing the counting bits question. So suppose we have the number as n equal to 4. We need to calculate the set bits, which is the 1 bit in 1 to 4. So which is, we have here 1, 1, 1, 2 and 1, totaling 5. So there are simple ways to do this, and we'll go with the brute force way to the optimal way. So the brute force method is basically that we iterate over num from 1 to n, and then we basically go through every bit. So the thing is, you don't have to go from 0 to 31, you just have to go from 0 to the log n and basically check if that bit is set and that place or not. So to check if it is set, we just have to check num and 1 left shifted by I. So this will calculate the number of set bits and give us the answer in on O of n log n time complexity. So brute force method might not be the best always, and now we can check for another method, which is the DP method, which is the of n time complexity. So something that you need to consider here is that when you have a number, suppose we have two cases. So one is for the even bit number, one is for the odd number. So for even number, let's take 4. We know it as 1 0 0, and if it is shifted by 1, then we'll get the same bits, which is same as in 1 0, right? So we have 1 0 0, which is 4. You right shift it, then you'll get it only as 1 and 0. And if you check how much bits are there in 1 0 0, it is just 1 set bits. And how many set bits are there in 1 0? It is also 1. So what you can say is the number of set bits in 4 is same as number of set bits in 2. Now let's take a case of the odd numbers. So suppose you have, say, number 5, which is 1 0 1. You have 2 set bits, 1 1. Suppose if it is right shifted by 1, so what do we have? If it is right shifted, we just have 1 0, which is 2, and 2 has only a single set bit, but our 5 has 2 bits. So what can we say? So if the number is an odd number, if it is right shifted by 1, we need to add an extra 1 to the answer, and then we can calculate it for 1 0, which is the 2. So this is basically becoming a DP problem, because we are memoizing or storing the value when we are traversing it from the num equal to 1 to num equal to n, right? So suppose if you want to get to know the number like number of set bits in 5, you know that it's already calculated for 2, because you're coming from 1 to n, correct? So we just have to say if it is odd number, we just have to add 1 plus do the take the value of the 1 shifted by 1, right? So this is for the odd case, and this is for the even case. In even case, we are having the same value as in for the one that is shifted by 1 in this case. Okay, now this is the optimal method. So this optimal method, if you want to read more on this, you can basically go to the GeeksForGeeks page and you can understand more, but I'll be quickly explaining this. I'll also show the diagram for this. So this is the optimal method, and we cannot understand it without a diagram. So let's suppose this is the number we are going to calculate it for, which is n equal to 5, right? So this is basically a pattern recognizing problem, wherein let's say we have n equal to 5, and as you can see that I have written the values from 0 to 5, which is 0 to n, and we have we have 0 1 0 1 0 1, and for this position we have 0 0 1 1 0 0, and like as we have learned in the high school that we have alternating just like that, 0 1 0 1, here 0 0 1 1, here will be 0 0 0 0 1 1 1 1. So that is the basic fundamentals in this. And here what we are doing is, first we'll need to calculate the highest power, which is basically less than this 5, which is take the log to the base 2 of the number n. So when we take the log to the base of 5, log n log 5 to the base of 2, we get what? 2 square. That is the maximum. So the maximum is 4. Maximum power of 2 is 4, which is less than 5, less than or equal to 5. So we'll need to set this 2 as our x. So x is equal to 2 is what I'm setting here. Okay, so we need to keep that in a box. And what we are doing here is, there is a general formula which is 2 raised to n minus 1. Sorry, 2 raised to x minus 1. 2 raised to x minus 1 into n. That will give us the total number of set bits, this 1 bits in this area. Okay, so let me revise again. So what I'm saying is, first we'll find the x, which is from the highest power, which is less than or equal to 5, and that will be the number 4, which is 2 square. So x is getting us 2, and all the numbers that is before that is this part, it will be having the numbers which is 2 raised to x minus 1. So 2 raised to x minus 1, how much is that? 2 raised to 2 minus 1, that is 2 raised to 1. So what this says is that there will be 2 raised to 1 set bits in each of these columns, right? Which is 2. 2 raised to 1 is 2. So we have 1, 1, which is 2 of them. Then we have 1, 1, which is 2 of them, right? And this formula, 2 raised to x minus 1 into n, will give us the total number. Sorry, this is 2 raised to x minus 1 into x. Sorry. 2 raised to x minus 1 into x. So we have, what do we have? We have 2 raised to x minus 1 2's in each of the columns. We'll multiply that with x. And what will we get? We get 2 raised to 2 minus 1 into 2, which is basically equal to 2 2's are 4. So we have 1, 2, 3, 4. 4 set bits, that is just before this 2's power, before the 4. And now that will be our first answer. And for our second answer, what we need to see is, as you can see that before 4 we have everything here as 0 to the left side here, right? Because it's 0 0 0 0 0 1 and so on. But after and including this 4, we'll be getting a 1 on this left side, correct? Right, which is the power which is less than 5 till the number 5. We'll be getting all these places as 1. So we'll get how much number of 1s? That is 5 minus the 2's power plus 1. Why plus 1? Because we need to take only this area. That is 5 minus 2 to the power of x plus 1. That is 5 minus 4 plus 1. That is equal to what? 2. 5 minus 4 is 1. 1 plus 1 is 2. Let's keep that in another box. Okay, so this is 4, this is 2. And what else do you see in this pattern? You see this tiny area here? What does it say? Wait, isn't the same as this area? 0 0 0 1 1 0 1 1. We have a part of that, that is 0 0 0 1. So what we'll be doing is, we'll be sending this into a recursion. Okay, we'll recurse this and get the value of only this. So if we put the value, if we put this box as p1, and if we put this value as p2 and this as a val, so our answer will be p1 plus p2 plus val. Now how do we calculate this val? So to calculate this val, what we need to do, we need to take the 2 raised to, we need to take the n minus 2 raised to how much is this? 2 raised to x. That will be 5 minus 4. right? 5 minus 2 square, that is 4, equal to 1. We'll store that in a box. So this basically means that we'll be sending this into a recursion. Sorry for my bad handwriting. We'll be sending this into a recursion. You'll understand that once you see the code. So we'll be sending this as a recursion, and this will be the value of n in the next recursion, which means, as you can see, we have 0 0 0 1. So we are asking our function to retrieve it using a recursion to get for the number n equal to 1, which is this small part. Okay, so let's see. So let me take my Sublime Text. Okay, so first of all, count set bits. If n is less than 2, we just return that value. So first we'll take the log 2 of the n, that will be our x. Then we'll take int p1 and we will do x into power of 2 raised to x minus 1. You remember doing that here? X into 2 raised to x minus 1, that is this value. Okay, I mean this is this value. The total value is this 4, that is p1, which is p1, 2 raised to x minus 1. Then we have p2, which is n minus 2 raised to x plus 1, which is this value, this 1, n minus 2 raised to x plus 1. Okay, that is just to include this area, like we do a minus b plus 1 to get the area within the range. That will be p2. And for the remaining ones, what we can do is we calculate int val equal to n minus power of 2 raised to x to get this area, and we'll be passing that through a recursive function again. So that is count set bits of val. And when we return p1 plus p2 plus this recursive answer, we'll get the answer, right? p1 plus p2 plus this answer, which is val. So that is set for this method, which is this is an optimal method. I think there are more optimal methods. You can get it in O of 1, I believe, but this method is O of login, and I'll be linking this below if you want to check it out. Thank you.